The question says in the anion, the carbon oxygen bonds are found to be of equal length. This is due to, okay, we have to find why the carbon oxygen bond length is same in this anion. First of all, we can draw the structure. We have a format ion. If I attach hydrogen, it will be formic acid. Okay, so we have COO, this is O and H is there, and this is O minus is there. O minus is there. Okay, pay attention carefully. You can see we have double bond, single bond and negative charge. Okay, double bond, single bond, negative charge. Hence we can say it is a conjugated system. What is the condition for the conjugated system? If we have double bond, single bond, double bond, this is conjugated system. Double bond, single bond, then negative charge. Conjugated system. Double bond, single bond, positive charge. Conjugated system. Double bond, single bond and lone pair is there. This is also conjugated system. These are the 4 conjugated system we have. And if the conjugated system is there, resonance will be there. Resonance. Okay. So double bond, single bond, negative charge is there, resonance will be there, in which pi electron density make a movement from one atom to another. Okay, for example, when this electron density goes this side, because it is a conjugated system, oxygen being more electronegative will pull the electron density. So what will happen? A structure we get, we have C and this converted into single bond having negative charge, and now it will form double bond, oxygen is there, this is what OH is there. Okay. So now you can see pi electron density is making movement from this carbon, no, this oxygen to carbon and this carbon to this oxygen. Pi electron density. Okay, from here to here you can see from this oxygen to carbon, carbon to oxygen. First pi bond is here, and in the next time pi bond is here. Yeah, double bond in this place. Second time double bond is here. Okay. So due to the resonance, you can see pi electron density is moving here, and when pi electron density is moving, you can see from this place to this place. First double bond here, second time double bond here. So bond length will also be same, because double bond, same bond length is there. So this is the reason carbon oxygen bond length will be same if we talk about the hybrid structure. So we have HO, this is C and it is O, and this is O is there, and double bond pi electron density is moving like this. This is the reason carbon oxygen bond length is same and carbon oxygen bond length is also same. This is the hybrid structure we have. Okay, we can mention the negative charge if you want to mention like this. Okay, and keep in mind hybrid structure is more stable than resonating structure. It has how many resonating structure? 1 and 2. 2 resonating structures are there. Okay. So first statement, we have the anion HCOO minus has 2 resonating structure. This statement is correct only because of the resonance. You can see this negative charge is distributed between carbon as well as oxygen. Carbon, oxygen, carbon, oxygen. Hence the bond length is same between carbon and oxygen. Another statement says anion is obtained by removal of a proton. No, that is not correct. We did not remove any atom. We did not remove this hydrogen. Okay, so this statement is incorrect. Electronic orbitals of carbon are hybridized. We didn't talk about hybridization also. And the COO bond is weaker than CO bond. No, that is not possible because the bond order in this case higher than this one. Higher the bond order, higher is the stability. And now it is talking about the weaker part. So we have the correct statement, that is option A. If you like this video, please share and subscribe to the channel.